All right, so here's another video helper for Lab 3. In this video helper, we're going to look at the second part of the lab, moving beyond stream profiles. Hopefully you figured out how to locate features along routes and see what's more important in terms of stream profiles, the geology or the incoming tributaries here in Pleasant Creek. So part 2, it says determine how land cover has changed within the Pleasant Creek watershed from 2006 to 2019. And I asked you to download 2 land cover data sets for those 2 years. I think I also asked you to get the land ownership as well, because I asked you to turn in a table showing land cover areas within the watershed from the 2 years. Also a map showing areas of land cover change, topography, and land ownership within the watershed, and caption describing your analysis of the area of change by land ownership classification and describing what types of change have taken place. And then there's a question based upon your reading in the journal using that basically the kind of Russell equation to think about erosion, whether or not you think that given what you see with land cover change and land use change, inferring that, do you think there was any increase in the erosion rate due to land cover change? Okay, so where do you get this data? So I've linked you to a bunch of data sets that you need to get. You can get land ownership from this website here, UGRC land ownership. Scroll way down and they give you these download options here. I've got the file geodatabase, so I can add it from here. So it'll come as a zip file and you'll have to extract it. Okay, so there's my land ownership. Now I might want to potentially clip that by my watershed because that's for the whole state. If I look at the attribute table, it's got a lot of info in there. So yeah, let's try to do that right off the bat. So if we go to geoprocessing tools and we say clip extracts input features that overlay the clipped features. So if we input features is the land ownership, and we want to clip it by the watershed, and that would be my PC watershed. Okay. And yeah, the output feature class will be land ownership clipped. Let's try to see if that works just as we have it right here. Okay, so I'm going to turn off the old one, and now we can see, yeah, we've got land ownership just within the watershed, so that's pretty helpful. So we can turn off the other land ownership, and maybe we can symbolize this a little bit. So we go and change it to unique values by, I don't know, owner agency. And so you can see private. What do we make private? We can make that color be, private will be, I don't know, white, I guess. And then apply. And then we'll go back. And then park service, let's make that like an outstanding green. Okay, so there's our national park. And then BLM, yeah, that's kind of a yellow gray, you know, lots of use for that potentially. So I'll use this weird brown. And then Forest Service, probably that should be green as well. Let's use a different green, I guess this yellow one. And then what else we got? State land trust areas, I believe. So the state of Utah, I will color that blue. Okay, and so yeah, there we have it. It's mostly BLM in the low areas, a little bit of private, and some state trust land. And then we go into the park, And then the other side, we have more BLM and state trust land, and then we get into the National Forest Service with a little bit of private land in there. Okay, so that makes a nice map for land ownership. Let me go back to map, clear my selections, and then just to make things a little clearer now, I'm going to change this to a black line. So there's Pleasant Creek and all the other streams coming into it. And make those other streams a little differently shaded. Maybe really light. Oof, don't really like that either. Make it gray. Yeah, that's okay. All right. So we've got our land ownership. The next two things that we needed were land cover. And, I'm wanting you to think about land use change. But we can only really, with remote sensing, we're mapping land cover, but you can maybe infer some related changes. Okay, so when you get to this landing page, you click download the data. And then, yeah, so then what do you download? Well, there's a lot of options here. I asked you for 2006 and 2019. So you can go directly and click on them. So let's see, let's go find 2006. Okay, so you want to be careful here because you can see land cover change index or all years. You don't want that. These are going to be huge data sets. You might be tempted because it gives you both data sets at once, but it gives you a bunch of other stuff too. When you click download, it's like 20 gigabytes. Don't want that. We're going to see that just downloading continental US 2006 data is going to be big enough. Okay, so I'm going to right click, save as, and I'll put that where I am working, hopefully. Documents, ArcGIS, projects, and cover. Put it right there. So even that file is 2.2 gigabytes. So you want to be real careful with this. I'm going to go back up here and click 2019 now, turn off 2006, and then I'm going to download 2019. Okay, so that's going to take a minute. So yeah, start those downloads earlier. Unlike me, I should have got it started while I was doing this other stuff. So I'll stop this video here and create up another one. So this video is really just covering how to port in and clip the land cover data for here in Utah and clip it to the watershed. Actually, there's something else we could do. We could look and see how much of the area is individual types of land ownership here. So let's open up this attribute table of this clipped area. And I think if we scroll way over to the right, we should see, yeah, shape areas. Okay, notice the area is not in the type of units we might want to deal with. So what I would, because I think I asked you about how much of the watershed is in different types of land ownership. There's a number of ways we could do this. We could like dissolve each of the types. We could dissolve by owner agency or something like that to kind of make multi-part features like we did before. And then, and that might be a good idea actually. Also, yeah, so let's do that first. So if we go to geoprocessing, let's go back to dissolve. And we're going to input the features of land ownership clip. And we're going to call it dissolve. We're going to dissolve by the owner agency, sorry, owner agency, not owner, because Owner is too simple. It's like federal, private, state. We want more detail. Okay, create multi-part features we want. Run. Okay, so let's close this one. Oh, look at how beautiful that was. It saved our attributes. So I'm gonna have to do that again. I mean our symbology. And yeah, so now we have our owner agency information. That's all we have, and we have the shape area. Let's add a field, and let's do area again for the name of the field. And it can be a long integer. That is fine. Yeah. Or if you want to know decimals, you can do float. Okay, and then we'll save that. And we're going to calculate geometry. So, by default, when you create a new shape file, it has shape length and shape area. But in this case, I guess the data set must be in decimal degrees because it's given me some pretty wonky numbers here, which looks like degrees. So, but we can calculate geometry right inside of the attribute field. You can say, I want to know what the area is. And yep, I can calculate it in the coordinate system of my map, which is in Northing and Eastings. And yeah, we want area. Okay, let's and then we can choose the unit. So if you want it to be in acres, if you think in acres or square kilometers, like square kilometers, I guess I can figure out what that is. Square miles. Just use the same units in each analysis you do. Tell me what they are. So we can see that BLM owns 44 square kilometers. Park Service is almost double that. Private is like a 10th of Park Service. State land is similar to private, and Forest Service owns the most. So, then we could show the statistics on that if you wanted to make a chart of that however you want. So that's pretty helpful. Okay, did we download anything yet? Not yet. Another way to look at that data, there's like some other geoprocessing tools you can use. So if we go back and you can go down to the spatial analyst toolbox. And inside of here, we can do a bunch of things. So we can do zonal statistics. Well, so you have these areas like of different parts of the ownership of the landscape. So if you wanted to know, for instance, like what the DEM or slopes are within the Forest Service land and things like that, you can use zonal statistics to get at that. So if you were like, oh, the zone field that you want to look at is these ones by owner agency, and you want to know what is the elevation values, it'll put a table out like that you could potentially join to here, and it'll just it's kind of cool. So we'll use this zonal statistics in a later lab. It's not required to complete anything in this lab. I'm just sort of telling you stuff. So yeah, it tells you how many pixels from that DEM are there. the area as well, in this case in square meters, minimum and maximum elevation data, the range in meters, the average elevation above sea level, and standard deviation, etc. So you can query DEM or any raster data by the zones of input features to get values out. And so if you wanted to know, for instance, say you had a Landcover classification, how many pixels within the Park Service are road versus forest, and within the Forest Service, how much is forest versus sagebrush or whatever, and your Landcover classification was in a raster format, which mostly they come at, you can get at that through zonal statistics. So this could be relevant to this lab as well. Okay, so that was zonal statistics. And I'm going to end this video just to keep them relatively digestible. And the next video, we'll talk about dealing with Landcover and Landcover change.